Let's practice some basic transformations with quadratics. We have our famous function f of x equals x squared, and we have the new function g of x is equals to the original function f of x minus 4. So this means 4 units down, we're going to replace f of x with what we know what it is, which is x squared. We're going to substitute. So the actual equation of g of x is x squared minus 4. So essentially we're substituting and replacing f of x with what it is, x squared. Now this itself is an equation, but here we're using function notation. Here we quickly recognize this is simply shifted 4 units down. So to sketch g of x, instead of drawing the parabola up here that hits the origin, we're going to shift it 1, 2, 3, 4 units down, and so it would look something like this. This is your g of x. Given y equals f of x plus k, what is the effect of k? What is the transforming effect of k? So like we just did, when k is negative 4, it moves 4 units down. And when k is positive 4, it's 4 units up. So k shifts it up or down. So for example, if k is equals to 3, so if you say y is equals to x squared plus 3, it means 3 up. And if k is equals to negative 1, y is equals to x squared minus 1, this is our k value, it means 1 unit down. D. Let's sketch this function here. It's nice that we have a different letter because we can refer to multiple graphs on the same graph. H. H can represent height. We like the letter H because it can be very descriptive as to what you're talking about. But this number here, minus 2, you have to think counterintuitively. When the number is just beside x with brackets, this actually means 2 units to the right. So this is the origin here. 1, 2 to the right, and that here is our parabola. E. Let's sketch this function here. Notice how the plus 1 here, inside the bracket means 1 to the left, and outside of the bracket squared, we have 3 units down. So we could sketch it pretty well. Let me just draw a nice coordinate system here. 1 left, 1, 2, 3 down. This is our vertex, and you can see we can roughly sketch the parabola here. And this is the vertex, which is negative 1 comma negative 3. Don't forget your signs. F. Given y equals x minus 2 squared plus 3, what are the coordinates of the vertex? So we're just practicing how to graph or practicing how to label things backwards and forwards. Hopefully you get good at this. We literally rip out these numbers. The vertex is going to be 2 comma 3. Notice how the y value remains the same. However, this number here beside the x, you have to think opposite of it. Negative 2 becomes a positive 2. Conversely, if there was something like this, x plus 1 squared minus 2, the vertex would then be minus 1 comma negative 2. Be careful. For g, height is a function of time. We don't always have to use y's and x's. We can use math to model anything, even physics. So height is a function of time, and we have a negative in front of the whole graph, which means instead of being a happy face, this parabola is flipped about the x-axis, and we have a sad face. So this is our t-axis. Instead of x, we have t. And instead of y, we have h. This is our h-axis. Last one here, we have z of x is equals to 2 times x minus 3 squared plus 1. So let's create a table of values for this function. Let's just try to meditate and think about what this means. So this is our x value, and this is our z value, which happens to equal 2 times x minus 3 squared plus 1. So let's plug in a couple points. Let's plug in 0. When x is 0, we're going to substitute 0 into here. we're going to get negative 3 squared, which is 9. 9 times 2 is 18, plus 1 is 19. Let's plug in 2 more here. Let's plug in a 1. When x is 1, 1 minus 3 is negative 2. Negative 2 squared is 4. 4 times 2 is 8, plus 1 is 9. And finally, let's plug in another point, 2. 2 minus 3 is negative 1. Negative 1 squared is 1. 1 times 2 is 2. 2 plus 1 is 3. Okay, let's just do one more. Let's plug in 3. 3 minus 3 is 0. 0 squared is 0. 0 times 2 is 0. 0 plus 1 is 1. Okay, so we did this one here. Use these points to graph Z. So we'll learn more about transformations next year properly, but let's just graph this quickly. Let me just give you a hint. This here is the vertex. It's going to be 3, 1. So 1, 2, 3, 1 is the vertex. And this means twice as tall. You're multiplying by a vertical stretch factor of 2. So normally the parabola, let's just draw a normal parabola here on the side. This is 0, 0. Normally you go 1 to the right and 1 up. This is 1, 1. And normally when you go 2 to the right, it becomes a 4 because y equals x squared. So here, this graph is stretched vertically by a factor of 2. So when you go 1 to the right, it should go 2 up. So this is our vertex. We kind of know that already. So we're going to go 1 to the right, 1, 2 up. So we actually know that it's going to shoot up like this quite steeply. So we go 1 left, and then you go 2 up. So this is going to be a quite steep graph, and yes, it will eventually cross the x-axis. This graph is not perfect, but hopefully you understand what's going on here. Okay, as you can see, we have some information. This here is a point, 0, 19. This happens to be the y-intercept over here, 0, 19. 1, 9. So this is 1, way up here, 1, 9. What about 2, 3? So this is 1, 2, 1, 2, 3. So roughly around here, 2, 3. And 3, 1. So this is 3, 1 is the vertex. So we graphed Z decently. And to find the Z-intercept, also known as the y-intercept, you set the opposite variable equals 0. So x equals 0, and we already have the result here in your table values. This is like the y-intercept is 19. It's where it hits this axis. So the answer is 19. Okay, so now it's your turn.